Okay, sir.
Okay, so in previous lecture we have discussed about this component, right? A quite
Yes, sir.
discussion about that, right? So basically in this lecture we will design a preform for this component, right? And
Okay, sir.
as well as a mold for this component. And a single cavity I will design, okay? And
Okay.
using NX Graphics CAD software or any CAD software you can use, right? Instead of
Yes,
this
sir.
software, but method should be same, okay?
Sir, can you
Yeah.
show me how to analyze the parting line
Of course. See, just for
in
example,
software?
of course. See, for example, this is the component we have. Okay. So
Yes.
as we know, first method is we have to check the draft analysis, right? So
Yes.
you know about that already. Now, for
Yes, sir.
example, if 1 minute, for example, this is the component I have. Okay, and I
Okay.
want a parting line for this component. है ना? So
Exactly.
basically, just for an example, 1 minute, uh, like for example, I'm looking this component from this direction, right?
Yes.
Okay, so basically, so you can say that parting line will be this, right?
Exactly.
Okay, so but for example, like if the parting line or the line is not visible for us, just for example,
Yes.
like a component look like
If there
this.
is no line. Yes.
Component look like this, a very sharp, you can say that, right?
Exactly.
So we cannot find out the exact parting line that where
Parting
will be
line.
it located, right?
Yep.
So similarly, for example, if I have another type of component, just for an example,
Mhm.
like 1 minute, I'm importing one more component. Or 1 minute, 1 minute.
Okay. A bit
Yes.
better than injection molding, but the complex components also are done in blow molding.
Understood?
Yes, sir.
Okay, I'm just hiding this one. Okay. Okay, so hiding this one also, which is the curve.
So, what do you think normal, if you consider any mold, either blow mold or injection mold, what will be the cost in India for construction of mold?
Injection mold or the blow mold?
Let's say both.
Uh, uh,
Approximate, don't say exact cost.
depending upon the component geometry, just for example, like if you are asking to the about the injection molding, right? So depending
Hmm.
upon the injection molding, it is depend upon the first of all part geometry, है ना? If the part is quite complex, then we have to machine by the VMC, by the CNC, or by the EDM. So basically, if we are using the mostly if we are using the EDM, depending upon the sharp edges into the component, right? So then
EDM
it
means electric discharge.
electrical discharge machining, right? So if we are
Okay.
using mostly EDM process, so it means it will become very costly, है ना?
Okay, if we reduce the EDM,
Though it will become quite cheap, not depending upon one more factor. This is the one factor, but depending upon most more factor, right? Like for example, this is depending upon the part geometry, and
yeah,
depending upon the material that we are choosing, and material choosing is depending upon the production, how much production we need of that component, intolerance,
okay.
है ना? And depending upon the location also here, right?
Yeah, that's why I'm asking.
हाँ.
That's why I'm asking, what will be the
Cost,
cost in
just for
India?
example, for the injection molding, approximately 1.5 to 3 lakh, है ना?
Okay.
1.5 to 3 lakh
If you
Indian rupees.
consider
Indian
with
rupees.
EDM,
Indian rupees, yeah.
no,
If I'm
EDM.
considering, like for example, depending upon the, for example, you have a component size like this, like bottle like.
Okay.
If you have a component size around less than 200 so your cost will
Okay.
be around this.
Because why I'm saying, I asked you some components, right? If they are the mold construction is manufactured in Italy, you know the cost, it is like 40 lakhs
40 lakhs in Indian
in Indian
rupees.
rupees.
Yeah, depending upon the, as I told you, depending upon the location. Okay, just for example, like if I'm making the component mold for this component, so here in India, I can manufacture this mold only in 1 lakh max, only 1
Okay,
lakh.
for example, I sent you a photo of tank, right? I tank.
Yes.
in a photos, I sent you a tank with, I thought it as a undercut, right?
You have sent already?
Yeah, before only I sent you.
Yeah, this one.
Yeah, this one. So what do you think this may be cost?
What is the dimension for this? Overall dimension?
The depth is 110.
110 mm.
Yeah, 110 mm.
Okay, 110, right?
Yeah. So
110.
the horizontal dimension is let's say 200 by 200.
200 and
By 200.
it will be 200, right? Like this.
Mm.
Okay, so its cost should be around what? In which material you need mold?
HDPE. Let's say steel.
Steel.
1.23 something.
1.23 means it is around C45, right?
Yes.
No, C45, or you can say that, right? So,
Yes.
so basically for this, I think maximum its price will be 2 lakh.
Or we can say 5 lakh.
For an example, just like depending upon the just for an example, we have in India, they're mostly I'm working with that company, right? Just for example, like we have a 3 location like Delhi, है ना, and Rajkot, है ना,
Okay.
Rajkot, and one more location is just for example MP, है ना, MP. In MP there is a Indore.
Okay.
So
Yes.
yeah, this is in this location there is a difference of the, for example, in Delhi I can prepare for this component I can prepare in 4 lakh, just for example, right? And in Rajkot I will prepare this mold in 2 lakh, and in Indore I will prepare this mold in 3 lakh, though depending upon the location, because the labor cost is very,
It's less.
that's why, है.
That's why I'm asking. So if this one I need to consider here, then it will be around 20 to 30 lakhs.
Yes, of course. Yeah, depending upon the currency also, basically. So depending upon that labor cost and the material and the purchasing, so everything will be matter, right? So from here, for example,
If I consider even if these people consider the same thing with higher configuration like 1.2379 also, then it will be less cost only, right?
Yes, of
in
course.
India.
Yeah.
Even if you consider transportation cost also, it will be very cheap for them.
Yeah, that's why you know about that. For example, you are from Italy, right? So
Yes.
you know already that lots of work or the design services provided by the India, right?
Yeah,
Because of the cheap labor, you can say that, right?
exactly.
Ah,
I suggested them to if they want to consider mold construction, they can consider India. I said them even in China, for example, they have a small tube, sir, like
Yeah.
let's say 50 mm,
okay,
like a moon shape.
okay,
Tube with the dimension of let's say 20 mm radius, 20 mm diameter,
okay.
or 30 mm diameter with the
Just understood this. Okay, I just started the recording. See here. So here, this is the component. Okay, and here you can see that what is the dimension of this component. See the length, you can say that, which is the 372 or 272.
270.
And diameter is the 82. So just for an example, if I am taking, as I told you, this is nothing but, for example, like PET material, right? PET.
Okay.
So for the PET material, what is the stretch ratio we can consider from? 9 to 12?
6 to 12.
9 to 12, right?
The maximum.
9 to 12 we can consider. So basically, so as I told you, this will be the nothing but X direction, and this will nothing but it will be the Y direction.
The height
Right.
will be Z, right?
No. This is not the height. I'm just length. I'm just consider the length right now. This is Y and this is the X. So basically,
Okay.
yeah, if I provide the wall thickness of this component, so it will become the X multiplied by Y, which is the biaxial ratio, right? Remember?
Okay.
Right?
Yes, sir.
Okay, so right now you can say that, so this is the complete ratio. You can say that this is the complete stretch blow stretch
Ratio.
value, right?
The
Blow stretch
maximum,
value.
minimum ratio of
This is the
XY
minimum
and
and this is the
maximum ratio
maximum.
of XY.
Yeah. So here you can see that this is the stretch blow molding, right? If this is the
Yes.
stretch blow molding, so we have to consider the minimum value, which is nothing
Yeah,
but 9. 9. If I divide by 9, sorry, if it is the 9, it will be the 3 multiplied by 3, right? That's why it will become
Yes.
9.
Yes.
So we can consider the 3 in x direction and 3 will be in y direction. Understood?
Yes, sir.
Okay,
Yes, sir.
so 3 is nothing but 3 is the value which I will consider, right? For find
Yes.
out the
The value.
value
the
of length of the
stretching.
preform
Yes.
and the diameter of the.
Okay.
Okay, so what is
So
the
3 by
yes
3 by 3 preform.
yes okay, so we have to divide by the 3. So generally we have to divide with the 3 if we are working with the pad. If we are dealing with the pad, right? Okay, so what is the dimension here for this? See.
272 by 81.
Okay, so again 1 minute.
272 length,
No,
81.
272 or 82, right? So
Yes.
you can consider the 280 and
Ah.
90. Okay, just consider the 280 and 90. So what will 280? 290 divided by 3. What is the value?
280.
Okay, 280 divided by 3. What is the value?
3 nines are 90. 3 nines are 27. 96
Okay.
point something.
So 90 divided by 3, it will be the 30. And
30.
What is the value of this?
96 point something.
So 96, just for example 96, right? Okay.
Okay.
So here you can see that if you are preparing the
The length of Parison
Length.
will be 96
Yeah,
and the
it will be
width
the
of Parison will be 30.
96 and the diameter will be 30.
30.
Now what about the wall thickness? The wall thickness will become 3 multiplied by 3 equal to 9. So basically, if for example after the blow of the component, we will get the 0.4 mm wall thickness, right?
Okay.
0.4 mm. So 0.4 or 0.5, just consider 0.5. 0.5 multiplied by 9. So what you will get?
5 by 10 by 45 by 10. 4.5.
Okay, 4.5 will be the wall thickness.
Thickness.
Thickness of the preform.
Okay, understood, sir.
Understood? Okay.
Yes, sir.
So you
So we need the
note
thickness
that.
of the Parison will be 4.5.
Yeah, you
The
note that
96
dimension?
will be, sir?
You note that dimension?
Yeah,
Okay.
96 by 30.
Okay. So just 1 minute. I'm just hiding this 1 minute. Okay. This is the neck portion. 1 minute. Okay. And I'm just using new plane and point and direction. I will take this one and this will be this and click OK. Okay, I'm
So
just
from
hiding this.
the neck portion we need to consider
Yes.
96 length.
Acha, what is the purpose of neck here? You see this portion. This is nothing but this is the locking purpose
To lock the
with the mold.
of the mold.
Basically this portion will be in. Basically, this is the constant.
The Parison
Neck
will
is
be
the
fixed
constant.
on the mold.
Yes, the neck is the constant, right?
Yes, sir.
Okay. So here, what is the diameter? Which we
30.
have here? 30. So 30 mm is the diameter. See? Okay.
The depth is
Yes.
96.
So 96 is the depth. So here 0.
Single direction.
Yes. So 96. Okay. And click OK. Okay. So we have to provide the one more thing, which is the 30.
Fillet.
Yes, fillet. It will be the 15 mm and click OK. See?
Why only 15 mm?
Yes.
Why only 15 mm, sir?
15 mm because the diameter is the 30, that's why I have taken the 15 mm.
Ah,
So
okay,
it will
okay,
create the
okay.
complete circle, right?
So if it is 45 by 2, 45 then 45 by 2.
Yes. And here thickness, right? Thickness, which will nothing but 4.5.
5.
Okay. See. So this is nothing but
The preform.
preform which we have created for the bottle. Now, but here you can see that we have to add this, right? So
From
we have to
the
unite
edge of
with
the-
this, yes, like this, and we have to provide the radius to this. See, see,
fillet. Okay.
yes, right? Just provide the 2 mm if possible. 1.5 I'm just providing 1.5. Right, see, and similarly I have to provide the radius here also.
Yeah.
1 point.
To make it even.
Yes, right. And similarly I
Rather
can
than
provide the
sharp
radius
edges.
here. Yes, I can provide the radius here. Control H. Understood? It is like this.
Yes.
Because it will
So-
it will not provide the, you can say that, 1 minute.
The sharp edges are dangerous, right? Anyway.
Yes, that's why. Right. Understood?
Yes, sir.
Okay, so this is nothing but this is the preform for these components. See,
Yes, sir.
but we have to use this component into the stretch molding, stretch blow molding process.
Yeah. So that means so we whatever we need the thickness, then like if we want thickness of 1 mm, then we need to consider 1 into 9.
Yes, depend upon the what material we are choosing. If we are dealing with the PET material, so we can consider the 3. Generally, if I take the calculation, so we have to take the 2.83 value, as I shown you before, right? 2.83
Yes, sir.
value. So basically 2.83 value, or we can consider the 3. So
Yes, sir.
quietly same, you can say that, right? That's why.
Yes, sir. I understood.
Okay, understood about these things. So this is
Yes,
nothing
sir.
but
And
this
then-
is the preform design for this, right?
How to calculate the Parison then?
The Parison basically is depending upon the component. Just for example, if
Let's say for this only.
just for example like this, right? This is the component we have. So here we have to consider the Parison. 1 minute. So here depending upon the wall, what wall thickness you need here? Tell me.
Let's say 2.5.
For the component.
Yeah.
So
Yeah.
if you are
Anything
taking the
right, we want like a assumption, we want 2.5 mm.
so 0.5 is not possible into this. Why? For if we are working with the Parison, so basically 0.5 is not possible. Why?
Because the wall thickness is very less.
Wall thickness is very less, and as I told you, we have to work with the PP, PC,
PP or PET,
HDP or LDP.
PA.
So minimum wall thickness for this type of component, we have to take more than 1 mm.
Yeah.
If
So that's why I'm saying we can consider 2.5.
2.5 is the large, 2 mm you can take, right? Just for example, 2 mm I am taking.
For example, right, I'm just saying.
So if you are like taking 2 mm wall thickness, so basically here just I'm not using calculation right now, right? Just
Okay.
So here you can say, for example, like this will be your die. See, just for example, so here this will be not your die, okay? Now consider
Yeah.
this value. See, so this neck will be into the prepared into the
Mold.
right? So this is not the constant now. So basically we have to
The starting will
Yes.
be taken.
Yeah, 1 minute. I'm just making something here. So basically here I have to prepare like this, like a draft like this, a draft.
Yes.
And one more thing, 5 or 10 mm apart from here. So
The
basically,
closing.
yes, and this portion I have to cut after
Yes.
the production, right? So this
Yeah.
will become the final component, right? Okay. Now here you can see that this is nothing but this is our mold. For example, like this is our mold. है ना.
Yes.
Now here I will provide pinch off, है ना. So here this from this and from this nothing but this will provide the pinch off. Okay, so here
To
your
make the excess material.
yes. So and similarly okay, so just consider this value. Okay, so now we have to prepare the preform. Sorry, Parison
We
will
can
be,
consider the diameter of the
Yes.
parison, right?
yeah,
Sorry, diameter of the
not
bottle.
diameter. So we can consider like this. See, it should be less than diameter wall thickness. 1 minute. Its wall thickness should be Parison wall thickness should be what 2 unit, right? So should be more than
Yes.
2 So its wall thickness is around 2.5 or 3 right? Okay.
Okay.
And diameter of this Parison should be less than diameter of the bottle.
Component.
Okay, so here what is the diameter of the bottle is about 82, right?
30.
So take the less than 15% of
82.
that.
Yes, yes, yes.
Take the less than 15% of that, right? So you can take 60 or the 50 you can take. Okay, or range will be the 2.5 to 3 you can take for the wall thickness of this Paris.
Okay.
So you will get the final wall thickness which is around 2 to 2.5 Understood?
No, sir. I got confused here.
Am I confused? Just for example, basically, if I am, for example, this
Pouring
is
the
something
Parison from the
Parison, right? Parison. So basically, Parison has a no. You can say that the not the
The
fixed
wall thickness
diameter.
can be controlled there.
Yeah, we cannot provide the fixed diameter to the Parison.
Exactly. Because of the
It should be less than diameter of the component first of all, which that's why it will become, this portion will become into the pinch off cut, right? Okay, so it will so basically this is the resting portion for the flashes material, right, or the excess material.
Yes.
Okay, so
Yes, sir.
yeah, so basically you can say that if you want to complete learn about this, so I think you have to wait for the Parison mold, right?
Okay.
Yeah.
Okay.
Okay,
No problem.
understood?
Yes. sir.
Acha, so you understood about the preform right now? How to design the
Preform, I
preform?
got complete idea.
Okay, so as we know that if we are designing or if we are working with the PET component, so basically we have to prepare the PET preform, right?
So if we can, for example, if you consider the same thing into PP, then we need to consider the minimum stretch ratio values.
Yeah.
And consider the, if for example, let's say PP has 6.
6. So basically then we generally you can say that 4 to 6. Okay, so we cannot go. So as we know,
The max.
if we
So
are
we need to consider 4.
yeah, if we are working with the PP first of all, okay, we can take the 4. The 4 means 2
So 2 by 2.
multiply by 2, right? So here you
So
can see
that means
that
272 by 2.
so here you can see that if we are working with the PP, it means component will be like this. Understood?
Yes.
It means there is no will be stretching with this. And if I am taking the material PP, so basically its wall thickness should be less than 1 or greater than 1 right?
Yes.
Greater than 1 So here you can see that. So what will be the thickness for this?
It's very high.
Not high. 2 multiply by 2, you will
One,
get the 4.
4.
So 1 is the wall. 1 is the final component wall thickness. So you will get 4 is the.
Yes. 4 wall thickness should be considered.
Yeah. So as we know that for the small component we consider the PP or the PC or the PVC material, right?
Yes.
So we can prepare the preform for that type of component, but we cannot go for the stretch blow molding, right?
Yeah, normal, like a normal injection molding.
Yes. Okay.
Yeah, for example, only we are considering, not about stretching.
Yes.
I want to, so it can be, if I have more examples, then I can analyze the concept.
Of
more.
course.
That's right.
So today we have discussed about the preform. In next lecture, tomorrow will be the holiday because tomorrow is the Holi festival.
Okay.
You know
Yes, sir.
about that, right? So basically, I was busy tomorrow. Okay, so
Okay.
after
On
that, I will
Saturday.
take the lecture. Okay, or what is
Okay.
the day? Thursday, right? So Friday. So I will take on Saturday class. Okay.
Okay, sir.
Okay.